means is we know that the equation that we'll write to represent the data in all of three of these tables will be written in the form of y equals mx plus b, which is slope-intercept form. And hopefully you remember, in slope-intercept form, the m represents our slope, and the b will represent our y-intercept. So that's what the two things will be that we are going to have to figure out in order to write this equation. We're going to have to figure out what the slope is in each data table and what the y-intercept is for each data table. And we're going to do this without the luxury of looking at a graph. We're only going to look at the numbers in a data table. So let's start with this first one here. We've got the x's on top, we've got the y's underneath. And let's start with this. We want to remember the two things we want to solve for. We want to get the m, the slope, and the b, the y-intercept. So those are the two things that we want to get. First thing, remember that the m, the slope, is equal to rise over run. The slope is equal to rise over run. So what really that is looking at is we're looking at how much is it going up and down versus how much is it going from left to right. To figure that out, what we can do is let's look at the x's and the y's. Which of these numbers deals with the up and down portion of the line? Well, that's going to be our y's. Which number, x's or y's, deals with side to side? Well, those are the x values. So let's look at how much the y's are changing, the change in y, divided by the change in x. All right, so let's see what they're doing. The x's are going plus 1, plus 1, plus 1, plus 1. The x's are all going up by 1. What are the y's doing? From -3 to -5 is minus 2. From -5 to -7 is also minus 2. From -7 to -9 is minus 2, and -9 to -11 is also minus 2. You would expect these numbers to all be the same because I told you right up front that this is going to be a linear relationship. So what is the rise over run now? The rise over run, the change in y up and down, this is always -2. How about the change in x? How much is it going from side to side? That is going up by 1. So every time we go over 1 on the x-axis, we're going down 2 on the y-axis. Over 1 on the x, down 2 on the y. And so the rise over run is -2 over 1, or just simply -2. So that's the first part. We got our slope. But the other thing that we need to do is we need to get our y-intercept. That's really easy to do when you're given the graph. But what can you do? How can you get that if you're only given the data table? Well, let me just show you a graph first off. If you are given a graph, this is just a random graph. This line does not represent the data in the table I just showed you. But how would you get the y-intercept here? Of course, the y-intercept is where our line crosses our y-axis. There's our y, there's our x. So our line crosses the y-axis right there. What are the coordinates of that point? Well, the coordinates are how much do we go left or right on the x-axis to get to this point? Well, we don't have to go at all. We don't have to move either way. So the coordinates of this point, the x-coordinate will be 0. The y-coordinate, how many numbers up the line do we have to go? We have to go 1, 2, 3, 4, 5, 6. So the coordinates of that point, the y-intercept, are x is 0, y is 6. X is 0, y is 6. So the key point here is the y-intercept always occurs when x equals 0. When x equals 0, the y-coordinate is our y-intercept. When x is 0, the y-coordinate is our y-intercept. Well, let's go back to our data table now. Remember what I just said, when x is 0, the y-coordinate is our y-intercept. Well, here's x is 0. the y coordinate must be our y-intercept. When x is 0, y is negative 3. So b must equal negative 3. So we got the slope. Now we just figure out what the y-intercept is. The last step is to just simply write this as an equation. And so the equation will be y is equal to our slope m, which we figured was negative 2, times x, plus our y-intercept, which we have now determined is going to be negative 3. So there's our equation. Let's look at another one.